you haven't been calling out of work as a technician in the Northeast, you realized it's getting close to 70 degrees on a daily basis. This means TXV hunting season is open, and it's anyone's best guess if they're going to operate correctly in come July. Let's talk about it. Welcome back, I'm Chris Morin with HVAC Pro Blog, and today we're going to talk about TXVs and low loads. What happens when we test them, and how can we make sure that the system is actually charged correctly? I'm going to be honest here. When it would reach 70 during the day, that doesn't mean the entire day. And when I was a service manager, I used to try to squeeze in as many service calls as possible, and I always ran into trouble when it was chilly in the morning. Now, let me frame this up for you. I found out some interesting information about TX valves when they made the change from R22 and 10 SEER to 410A and 13 SEER, of course, and above. Did you know that they actually adapted the TXVs that were already being manufactured to accommodate R410A systems? At the time, manufacturer Danfoss claimed that putting in a TX valve would actually increase system efficiency between 15 to 26%. But thousands of non-optimized valves were installed, and they don't operate very well under low loads. And this tends to lead to technicians overcharging systems, which obviously does not get the 15 to 26% increase in efficiency that we hope for. Never mind the serious issues of getting liquid back to the compressor under these low load conditions. Anyhow, under a really low load, these valves tend to shut down and operate just like a fixed orifice, and we know how that low load situation impacts fixed orifices. They tend to start to slug the compressor. The manufacturer Emerson actually figured this out really quickly in 2008 and started manufacturing valves specific for R410A called their C series. This valve would actually let the system reach a steady state without hunting under low loads. And get this, the unit would need less refrigerant. In turn, this let manufacturers produce evaporator coils that were actually smaller in height and surface area. Also, these optimized valves would actually increase the SEER efficiency by half a point. So from 13 to 13.5, let's say, more than the non-optimized valves that were just adapted from R22 to 410A. Now, the biggest influence for this valve was early season maintenance, because now technicians and installers could actually get the refrigerant charge right under low loads. If you didn't know, when charging under a low load, it's really easy for the technician to overcharge a system. One time I was actually on a job site just like this, and it was only 64 degrees outside. At first, the TX valve was hunting, and we could see that on the suction pressure and the superheat going up and down. And we thought right off the bat, well, it's under low load. Remember, it's TXV hunting season. But when I saw what valve it was, I immediately recommended that the technician tighten and insulate the sensing bulb. Sure enough, the superheat pegged to 8 degrees Fahrenheit, and of course the subcooling rose to 22 degrees. Of course the technician had to pull some refrigerant out, but it wasn't because he overcharged the unit. Believe it or not, it was because it was a short line set. Now, on the other end of the spectrum, undercharged systems, there's been tons of studies done to talk about how undercharged units impact efficiency. One in particular, quite some time ago, was done by the physical engineers over at Purdue. Apparently, the SEER and COP for heat pumps are not impacted until the refrigerant charge reaches 70% of the recommended charge or less. Of course, this is with a TX valve. The efficiency hit on a fixed metering device would happen at a much higher percentage. And with a TX valve, this is the point where it shuts down and acts like a fixed orifice. That unit that would reach 25 to 30% undercharged would actually decrease efficiency by 16%. This equates to a system using $100 more per ton per year compared to a system that was charged correctly. That adds up drastically over the life of the system and the length of the time the homeowner lives in that house. So, because we know this impact, technicians tend to charge the system up and just do the homeowner a solid, make sure they have a little extra in there. And I want to make sure you avoid this, because come July, we're going to start causing more system issues like failed compressors and decrease in efficiencies because the condenser coil starts to get clogged. So if you're out there on maintenance under low loads, First, I want to make sure that you check that sensing bulb. Make sure it's so tight you can't move it with your hands, and insulate it. And you need to remember, just because those old TX valves used to hunt under low loads doesn't mean the new ones will. You really need to take the time to diagnose the TX valve first before you think it's a refrigerant charge problem. Thanks for joining me again this week at HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis. See you soon.